Hi, so today I'm going to be teaching you, whoever is watching this, a little bit about metals and their characteristics. We'll do some analogies. It's going to be real fun. Okay, so first we'll start with some characteristics. So they are mostly all solids. There's a few exceptions, but if you just have in your head that they're solids, you'll be good. And they tend to bend instead of break. And to make sense of this one, I usually think about like tin foil. You know, it you have to bend it around like the edge of your bowl, otherwise your leftovers will go bad in the fridge. So that's usually what I think of for bending metals, because it's kind of a weird concept. Yeah. And then they conduct electricity well, and we'll get more into this later, but I did draw a little light bulb just to be fancy. They are shiny and lustrous, which I'm sure everyone who's watching this has seen in their daily life. Yeah. And there's going to be some key terms. So one of them is malleable, which means that they can be hammered or bent into shape, which is kind of like the tinfoil thing again. You bend it, or like, I don't know, if you had like a block of metal, you just put a little hammer, bang, bang, it's got a dent in it. It doesn't necessarily like crack, as something else would. And then ductile, which means they can be drawn out into wires. So what I've drawn here is called the sea of electrons. So basically, what's happening is we have the positive metal ions and negative valence electrons. So the valence electrons aren't necessarily tied to one ion. They kind of just like a sea, like the waves, they flow through freely, and they aren't attached to a specific one of those aluminums. And I did realize after I made this that there is a circle tool, but you live and you learn. So, and here I have a little 3D picture of it because I wasn't exactly sure how to draw it. So as you can see, the green are the ions, and then the purple are the negative valence. So more about the sea of electrons. It's called also community electrons, and they shift easily, and the atoms slide past each other if a force is applied because their electrons aren't attached to them. They are able to like slide and move and become different shapes. That's why they bend and can be drawn into wires, which is malleable and ductile. And so here I found this analogy online, which I thought was good to use. It's if you like were to dump a bunch of golf balls in your bathtub, I don't know why you would do that, but if you would, they would make a nice pattern, and they would still have spaces between them of just like air. But then if you plug the drain and turn on the water, it fills up with water and fills in those spaces between the golf balls, and that water is like the valence electrons. It flows freely, and that also gives you the sea of electrons idea. And then for my last slide, I was showing the ductileness of drawing out into wires and how it conducts electricity. So basically what we have here in the corner on the bottom left is a power plant, and then there's wires going from the power plant to your home. So what's happening is the wire, they're shooting electrons out of it, and what I drew is the electron going into that zoomed in part of the wire. That's what that is. And there's an empty circle to show where it would go. And then it flows through those community sea of electrons. And then you can see on the other side that one is popping out. And that's going to be sent eventually to your home, which will create the electricity that we all, use every day. So basically, that's it. I hope that this has been helpful. There's lots of good things online too, more videos you can find. So I hope you kill it on your midterms and finals. You got this. Not exactly sure how to end this. Okay, bye. I'm just kidding. Okay, bye for real. Yeah.